Hello guys, so for the problem one, based on the example data at 0.05 level of significance, can we conclude the average price of the sanitizer in district A is 10.5 ringgit? Make your conclusion using the p-value approach. P-value approach. So later we need to use this approach. So with the aid of Microsoft Excel. So by doing these questions, we need to use the Excel to help us to find the answer. So first, we need to move the data into Excel. So this is the data from the questions, which is the price of sanitizer. And this is dummy. We put it on 0 because we use the t-test, 2 tail, and 2 samples. So we need to have another row. So after we have this data, we go to data and then data analysis. So we choose t-test 2 sample assuming unequal variances. Okay, so why we choose t-test? Since the questions does not show out the population of standard deviation, so we use t-test instead of jack test. Okay, so we click OK. Okay, here go variable 1 and variable 2. So the variable 1 we choose here, x until 9.7. And then for the variable 2, we choose dummy. Okay, so for the mean difference is 10.5 and label alpha we choose 0.05. Two of this is based on the questions. Okay, so output range we choose see where we want to show the table lah. Okay, so so here is the table come out, the t-test. So we just ignore this column since we didn't use it, and we since this data is 2 tail, we are 2 tail, so we only use 2 tail. So we just ignore it 1 tail, and then we can know the mean, variance, observation, and so on. So after we get, then this is the data that the table that I edited. So here show the mean, variance, number, population mean, and so on. Okay, so we move to Microsoft Word. Okay, so hence we know from the table, we know that alpha is 0.05, mean is 10 point something, and so on. So we move to step 1. So step 1, state hypothesis. No hypothesis is mean population equal to 10.5. Alternative hypothesis is mean population unequal to 10.5. Step 2. So we need to set a decision rule. Since the question is 2 tail t-test, so alpha is 0.05 and degree of freedom is 6. So p-value is 0.8018. So this is, we can find it from the table lah. So we can make the decision rule, which is the first one, reject H now if p-value is smaller than alpha, which is 0.05, and do not reject H now if p-value larger than alpha, 0.05. So next, we go to step 3, find the p-value. So from the table above, we know that the p-value is 0.802, sorry, okay? So step 4, make decision. So by using p-value approach, we do not reject H now since the p-value is equal to 0.8, is larger than alpha 0.05. Okay, get it? Okay, so step 5, make conclusion. We can conclude that the average price of sanitizer in District A is similar to the 10.5 ringgit. So that's all from me. Thank you.
Okay, hello everyone. I'm responsible for question 2. So let's look at the question first. The question want to find brand A, whether brand A is lower than brand B. So from there, we just extract the data, brand A and brand B, and go to Excel. Okay, we just basically just copy and paste brand A and brand B, and then we go to data analysis, and click t-test 2 sample assuming unequal variances. Click OK, and we can see variable 1 and variable 2 range. So we just press this and just drag the entire thing, enter, and the data assigned to. So press brand B, do the same as well. So since the question say the alpha is 0.1, so we put 0.1 label, and then mean is 0, click. We put it on a new worksheet file and press OK. So we do a little bit of adjustment. From there, we can see the whole thing just pops up. So this is what we want to find. Everything's right here. So we go back to Word, form our hypothesis, and then set the decision rule. The standard deviation is unknown, so t-test it is, just like what we chose. It is one tail because this there is no equal sign in the question. Left tail, of course. And then step 3, we find p-value. So since Excel calculated the p-value, which is the right tail, but we wanted left tail, so we do calculating minus the p-value on the Excel, and we get this. So step 4 is make the decision making. So we reject H alternate since the p-value is larger than 0.1. So conclusion, no, brand A does not have a lower price compared to brand B. In conclusion, the average price of brand A sanitizer is higher than or equal to the average price of brand B. That is my presentation. Thank you.
Okay, hey guys, I'm doing for the problem 3. So as we can see, at the 0.05 level of confidence level, can we make a conclusion that on average the price has not changed? So we will make our conclusion using the p-value approach with the aid of Microsoft Office Excel. So as we can see at the table 3, there is before and after. So for the answer, based on the table below, we can see that the t-test pair 2 sample for the mean. So this is all the mean and the p-value. So for getting this data, we go to Microsoft Excel and we go to the data. But before that, we need to include everything, the data at the table to the cell. So after that, we will press the data and go to the data analysis. So we will choose the t-test pair 2 sample for the mean. So we press OK. So after that, for the variable 1, we can see that, and we will drag everything for the before that B cell into the variable 1. So after that, for the after, the price after is we put in the variable 2. We will drag everything and the data will go inside. So for the hypothesis mean, we will put 0 and we tick the labels as the alpha is 0.05. So I will prefer tick the output range. So I will press any cell at the Excel. So I will press OK. So the data will come out. As we can see, the mean, the observation, the person correlation, and the hypothesis mean, and the p-value. The p-value got 1 tail and 2 tail. So we go back to the question. So for this, in this particular case, the question say that the price has not changed. So we are not testing a particular direction, higher price or lower price. So this is a 2-tail test. So we have to take a look at the result for the 2-tail test. So we will ignore the 1-tail test, and next go to the state of the hypothesis. For the null hypothesis, the hypothesis mean equals to 0. Alternative hypothesis is the hypothesis mean not equal to 0. So we claim that since the alternative hypothesis contain the not equal to symbol, this is 2-tail test. So we move on to step 2. We will set the division rules. If p-value smaller than significance level, we reject the null hypothesis. But if p-value higher or larger than significant level, we will fail to reject the null hypothesis. So we move on to step 3. Find the p-value. From the table above, taken from the Excel, we can know that the p-value is 0.206, which is this one. Okay, so we move on to step 4, make decision. As we know that p-value is larger than significant level, which is 0.206, more than or larger than 0.05. So we are failed to reject the null hypothesis since the p-value is larger than significance level. So the last step, which make conclusion, there is not sufficient evidence to conclude that the price sanitizer has changed after the COVID-19 pandemic. So that's all from me. Thank you.
Hi guys, so I will do the problem 4. So the question given is 90% of confidence levels. Can we conclude there is a significant difference in mean price of 3 brands of sanitizers? So we're using the p-value to approach in Microsoft Office Excel. So we open the Excel and copy paste the data from the question and click the data analysis. It will show in this question I used the ANOVA single factor. And this is because it's the one-way analysis of variance is used to determine whether there are any statistically significant difference between the means of 3 or more in the band's groups. So click OK. So we'll see the input range. I will select from the A2 from C6 and group by columns, label in first row. And the baseline question is alpha is 0.1. And output range I put in as A and click OK. You will see the p-value is 0.97722. And back from the words. So from the step 1, we need to state the hypothesis. For the no hypothesis, mean 1 is equal to mean 2 and mean 3. And the alternative hypothesis is at least one mean is not equal. So next, step 2 is set the decision root. First is reject null hypothesis if p-value is lesser than alpha value, which is equal 0.1. Another is do not reject the null hypothesis if p-value is larger than alpha value. And step 3, we will find the p-value from table above taken from Excel. We know that the p-value is 0.971722. So for the make the decision is do not reject the null hypothesis, seeing the p-value is larger than alpha value. So in the conclusion, there is not significant difference in mean price of the 3 brands of sanitizer. So that's all for me. Have any question?
No questions.
Okay, thank
Perfect.
you.
Thank you.
Okay, we come to the last question, which is the problem 5. So for the A part, we have to run a regression analysis based on the data, table 4, using the Microsoft Office Excel. So we copy the data first, okay, and we open Excel and paste here. So first we go to data, we choose data analysis. So we're choosing a regression, click OK. Then for the input Y S range, we drag from here. For the S range, okay, this is the Y range and the S range input, and we have to take the labels. Output range, I prefer put at G. Okay, then we click OK. So here we will auto generate all the data which we need to solve the problem 5. I do some adjustment first. Okay, let's go back to the A. So for the A, we have to propose a regression equation. So we go back to the Microsoft. So this one is for the equation. So we just substitute the beta, which is the intercept coefficient, 21.293 plus x1, 3.103 x1 plus 4.69x x2. So this is the regression equation for the number of sales made by an employee. So for the B part, I will pass to my partner, Eleanor Tan. She will continue it. Thank you. That's all for my part.
All right, so for my part next, for question B, we have to interpret the coefficient value of each independent variable in the model. So the coefficient value is also represented by the symbol beta. So beta I indicates that a change in the unit in xi will change the value of y by as much as the increase or decrease in the beta I unit given. That the other independent variables remain constant. So this means that for beta 1 or for coefficient 1, the value is 3.103. And this implies that an increase in the number of years that an employee has been with the company will increase the number of sales made by that certain employee by 3.103. And next, the coefficient for the second value, or beta 2, is 4.698, which implies that an increase in the score of an employee on a business aptitude test will increase the number of sales by 4.698. Next, question C. Is each independent variable sharing a significant linear relationship with the dependent variable? So first, we will look at the first coefficient. For the hypothesis for beta 1, the first step is to state the hypothesis, in which the null hypothesis is beta 1 equals to 0, and it shows that there is no significant linear relationship. And the alternative hypothesis is beta 1 does not equals to 0, where there is a significant linear relationship between the independent and dependent variable. Second step, we will set the decision rule. So we will reject the null hypothesis if the p-value is less than alpha at 0.05, and we will not reject null hypothesis if p-value is larger than alpha value. So next, we have to find the p-value according to the Excel that we did just now. So as you can see from the table here, the p-value for the first coefficient will be 0.1785. You can summarize it to 0.179. So next, we will make a decision. As p-value is 0.179, it is larger than the alpha value at 0.05. Therefore, we will not reject the null hypothesis. And we can make a conclusion that there is no significant linear relationship between the number of years an employee has been with the company and the number of sales achieved by that employee. So next, we will do the hypothesis for the second coefficient. Again, we will first state the hypothesis. So null hypothesis is beta 2 equals to 0, so that shows no linear relationship. And the alternative hypothesis, where beta 2 does not equals to 0, and it shows that there is a significant relationship. So the second step, set the decision rule. It will be the same as the first hypothesis, in which we will reject the null hypothesis if p-value is lesser than alpha value, and vice versa. Next step is to find the p-value. Again, we will look at the table above, and we can see that the p-value for the second coefficient is 0.07885, or 0.079, as I have written here. So we can make a decision based on that p-value. Because the p-value is larger than the alpha value at 0.05, we will not reject the null hypothesis. And we can conclude that there is also no significant linear relationship between the score of an employee on the business aptitude test and the number of sales achieved by that employee. So we have explained all of the questions from problem 1 to problem 5. Does anyone have any questions? No? No questions?
No.
Very
clear.
clear.
All right, so I think we can
Clear.
wrap up our discussion.
Okay.
Thank you, guys.
Thank
Thank
you. Thank you
you.
so much. Bye bye.